humans, the most advanced species on Earth. From the first flicker of fire in the prehistoric dark caves, to the flicker of screens that bind us together from every corner of Earth, our story is one of relentless progress and unyielding curiosity. Today, we stand as architects of the incredible, builders of worlds within worlds, harnessing the forces of nature to power our cities, cure our diseases, and reach out to the stars, something that people 250 years ago couldn't even imagine being possible. Today, we'll take a closer look to the beginning of the Industrial Revolution in the 1760s, examining how its breakthroughs radically transformed the world at that time and continue to impact us today, and then we'll go further, to explore what the next 300 years of advancements might hold. The 1760s marked the dawn of the Industrial Revolution, an era that transformed the world in profound ways. During this decade, the steam engine emerged as a groundbreaking innovation, sparking a series of changes that would reshape how people worked, produced goods, and lived. Imagine the era's landscape: skies clouded with factory smoke and the relentless rhythm of machinery. This was a time of significant transformation. The steam engine revolutionized production and transportation, paving the way for the modern world we recognize today. Beyond transportation, the steam engine propelled industries forward, powering factories and enabling mass production. This surge in productivity and connectivity laid the groundwork for economic growth and urban development. The 1760s, therefore, weren't just about the steam engine as a marvel of engineering. They were about the pathways it opened, the industries it reshaped, and the global society it helped forge. By the 1780s, James Watt's enhanced steam engine had begun revolutionizing industries, setting the stage for an era of mechanized production and altering the workforce and societal structure. This technological leap was further amplified in the early 1800s with the advent of the first commercial railways, notably the Stockton and Darlington Railway in 1825 and the Liverpool and Manchester Railway in 1830. These railways, powered by steam, transformed travel and trade, connecting towns and cities like never before and ushering in a new age of mobility and economic expansion. The impact was profound, shrinking distances and fostering a cultural exchange that redefined the sense of a smaller, more interconnected world. From the 1780s to the 1830s, the rise of the factory system revolutionized production. Factories centralized labor, leading to massive urban growth as people flocked from farms to cities. This rapid urbanization reshaped society, culture, and daily life, marking a shift to a world ruled by the factory clock. As the Industrial Revolution reshaped the physical world in the 1760s, the 1830s brought about a revolution of a different sort. The invention of the telegraph marked the beginning of a communication revolution, connecting continents and people closer than ever before. This remarkable device, born from a spark of genius, allowed messages to be sent over vast distances in mere minutes, a concept almost magical at the time. It shrank the world, binding continents and communities closer than ever. The telegraph not only changed the speed at which information traveled but also transformed business, diplomacy, and personal communication, setting the stage for the connected world we live in today. Then, in the 1840s, humanity opened a new window to the world: photography. For the first time, we could capture and preserve moments as they were, freezing time in a way that words could never achieve. This innovation changed not just art and journalism but also the way we remembered our lives and understood reality. Photography's ability to record and share visual stories sparked a cultural shift, influencing everything from family heirlooms to historical documentation. Transitioning into the late 1870s and 1880s, the invention of the electric light bulb did more than just banish the darkness of night. It ignited a transformation of society and industry. Cities, now alive with light at all hours, became hubs of activity and innovation. The spread of electrical power brought about a new era of productivity and convenience, impacting every facet of daily life. This era of electric light was a beacon of progress, driving forward countless innovations and permanently altering the rhythm of human existence. While the electric light was transforming cities into beacons of innovation, the 1890s brought magic to the airwaves with the birth of radio, further shrinking our vast world into a connected community. Marconi's pioneering work turned the dream of wireless communication into reality, shrinking the world in unprecedented ways. In the next decade, the radio began transforming military and commercial communication, and by the 1920s, it had entered homes worldwide, bringing news, music, and a sense of global community directly to listeners. From the late 1880s into the early 1900s, the automobile made its debut, redefining personal mobility and freedom. The foundation for the automobile industry was laid in 1886 when Carl Benz patented the Benz patent motorwagon, marking the birth of the modern automobile. This innovation paved the way for the mass-produced vehicles of the early 20th century, culminating in the launch of the Ford Model T in 1908, revolutionizing accessibility and affordability. This era of automotive innovation transformed not just transportation but also society at large, fostering the growth of suburbs, the creation of highways, and a cultural shift towards individualism and mobility. The automobile's rise marked a pivotal shift in the human journey, steering us towards a future at a pace once unimaginable. In the 1920s, a significant digital seed was sown with the conceptualization and creation of the first computers, like the 1927 differential analyzer. These early machines, initially designed for complex calculations, were the forerunners of the digital age. They laid the groundwork for a revolution that would unfold over the following decades, changing how we work, learn, and communicate. The introduction of computing technology in this time signified more than just progress. It acted as the bedrock for the future information-driven society, and crafting a pathway for a future deeply entangled with the digital world. As we transition from the 1920s to the 1930s, a new form of entertainment and communication arrived into homes of the people, the television. This revolutionary technology transformed the way people received information and enjoyed leisure, bringing moving images and sound directly into living rooms. By offering a window to the world, television reshaped culture, politics, and social dynamics. It became a powerful medium for storytelling, news broadcasting, and shaping public opinion, making it one of the 20th century's most influential innovations. During the 1930s and 1940s, humanity harnessed one of the universe's fundamental forces, nuclear power. The first controlled nuclear chain reaction, initiated in 1942, marked a turning point in science and technology. This breakthrough led to profound developments, from the devastating power of nuclear weapons to the promise of clean, abundant energy from nuclear reactors. The duality of nuclear technology posed new ethical questions and challenges, even as it offered solutions to some of humanity's most pressing problems, forever altering the global landscape and our relationship with energy. From the 1930s to the 1950s, the development of jet engines propelled aviation into a new era. Jet-powered aircraft significantly reduced travel time, making the world smaller and more interconnected. By the 1950s, commercial jet airliners began to dominate the skies, offering faster and more comfortable travel across continents and oceans. This era of rapid aviation advancement not only revolutionized travel but also had far-reaching effects on global commerce, culture, and connectivity, ushering in an age of globalization previously unimaginable. In 1958, a revolutionary leap in technology occurred with the invention of the integrated circuit by Jack Kilby and Robert Noyce. This pivotal innovation shrank the size of electronic devices while exponentially increasing their power and reliability, paving the way for the digital age. Its invention marked a turning point, leading to an era of compact, efficient technology that will become the cornerstone of the future interconnected world. The 1960s also witnessed the dawn of a new era in global communication with the launch of the first communications satellites, like Telstar in 1962. These orbiting beacons transformed the way the world shared information, making real-time, international television broadcasts and long-distance communication a reality. Satellite technology rapidly became a fundamental component of global networks, facilitating everything from television and radio to GPS navigation and internet connectivity. The advent of satellite communications not only connected continents but also shrank the world, enabling an unprecedented exchange of information and culture. The late 1950s and early 1960s marked humanity's audacious leap into the final frontier, space. The launch of Sputnik by the Soviet Union in 1957 ignited the space race, expanding our understanding of the universe and showcasing the realm of possibilities beyond Earth. This period was not merely about technological feats, it represented a new vision for humanity, one that extended its gaze past the confines of our planet and into the vast cosmos. The global excitement and ambition sparked by Sputnik set the stage for a decade of extraordinary space exploration achievements. In 1961, Yuri Gagarin's historic journey as the first human in space captivated the world, pushing the boundaries of what was thought possible and intensifying the rivalry between the United States and the Soviet Union. This era of discovery and competition saw a series of groundbreaking missions, each one daring to go further than the last. The pinnacle came in 1969 with NASA's Apollo 11 mission, when Neil Armstrong and Buzz Aldrin set foot on the moon for the first time in human history. The 1970s witnessed a groundbreaking leap in biotechnology with the advent of genetic engineering, particularly through the development of recombinant DNA technology. This scientific breakthrough has had far-reaching implications in medicine, agriculture, and beyond, offering the promise of tailored medical treatments, hardier crops, and a deeper understanding of the blueprint of life itself. Genetic engineering didn't just open new avenues for research and development, it also sparked important discussions about ethics and the future of human enhancement and biodiversity. Initiated in the 1970s and becoming fully operational in the 1990s, the Global Positioning System, GPS, started as a navigational tool for the military but soon expanded to revolutionize navigation and positioning for everyone. The widespread adoption of GPS technology has reshaped transportation, logistics, and personal travel, making it an invisible yet essential part of modern life. As we transition from the 1970s to the 1980s, a digital revolution was unfolding that would fundamentally alter the fabric of daily life. The era of personal computing was in full swing with machines like the Apple II, Commodore 64, and IBM PC, transforming the concept of computing from a specialized tool to a household staple. These devices democratized digital technology, making it accessible to the masses and igniting a revolution in how we work, connect, and entertain ourselves. As this transformation took root, another technological marvel was evolving: the mobile phone. From the first call made in 1973, mobile phones underwent a rapid evolution throughout the 1980s. They became more compact, functional, and indispensable, transitioning from luxury items to essential tools of communication. This era didn't just witness the birth of widespread computing and mobile communication, it was the foundation upon which our modern, digitally world was built, reshaping social interactions, business, and entertainment in ways that people of the past couldn't have even dreamed of. In the 1990s, the internet transitioned from an academic and military network to a global phenomenon, reshaping every facet of society. The creation of the World Wide Web and the launch of user-friendly browsers brought this powerful tool to the masses, sparking the dot-com boom and a new era of digital communication and commerce. Information, once confined to libraries and institutions, was now at the fingertips of anyone with an internet connection. The completion of the Human Genome Project in 2003 stands as one of the greatest scientific achievements of the 21st century. Deciphering the entire human DNA sequence opened new frontiers in medicine, genetics, and our understanding of life itself. This monumental milestone has paved the way for advancements in personalized medicine, gene therapy, and our understanding of genetic diseases. In the 2000s, the advent of mobile internet and the evolution of smartphones marked a big shift in technology and culture. The release of the iPhone in 2007, in particular, revolutionized personal technology, combining a phone, internet browser, and multimedia into a single small device. As we enter the 2010s, the digital revolution takes on a new dimension with the explosive rise of social media and smart technology. Platforms that began as simple ways to connect with friends and family quickly evolved into complex networks influencing every aspect of society, from personal relationships and cultural trends to politics and global communication. The 2010s witnessed a groundbreaking revolution in biotechnology with the advent of CRISPR gene editing technology. First adapted for genome editing in 2012, CRISPR has since opened new frontiers in genetic research and medicine. This powerful tool allows scientists to edit DNA with precision, holding immense potential for treating genetic disorders, enhancing crop resilience, and much more. Throughout the 2010s and into the early 2020s, two distinct yet equally transformative frontiers of human ingenuity have surged forward. In the realm of digital technology, artificial intelligence, and machine learning have revolutionized how we live and work. Innovations ranging from predictive diagnostics in healthcare to intelligent assistants in personal devices have permeated various sectors, dramatically altering the landscape of industries and daily life with promises of even more transformative changes ahead. Simultaneously, the quest for the stars has been reinvigorated within the human spirit, significantly propelled by the pioneering endeavors of private spaceflight companies. Landmark achievements like SpaceX's successful landing of an orbital rocket booster in 2015 and the launch of the Falcon Heavy in 2018 have rekindled the spirit of cosmic adventure and exploration. Alongside SpaceX, Blue Origin and other companies are advancing the prospects of commercial space travel, each contributing to a burgeoning industry that's making the once distant stars increasingly within our grasp. Starting with 2025, graphene, a single layer of carbon atoms, had a fast and significantly development, promising to revolutionize industries with its extraordinary properties. In 2028, humanity's age-old dream transforms into reality as the first astronauts set foot on the red dust of Mars, an event broadcasted live to billions, heralding a new era of exploration and colonization. The subsequent years are marked by rapid advancements and bold endeavors. By 2040, Mars boasts its first permanent settlement, Unity Base, symbolizing international cooperation and scientific endeavor. During the same period, on Earth, graphene's impact was undeniable. Its exceptional strength, conductivity, and flexibility had revolutionized multiple sectors. Electronics had been transformed with ultra-fast, efficient, and flexible graphene circuits and displays. The construction industry had become more robust and durable by incorporating graphene into composites. Energy storage had leaped forward with graphene-based batteries and supercapacitors, offering superior performance and revolutionizing everything from electric vehicles to portable electronics. Even space exploration benefited from graphene's lightness and strength, making it an ideal material for spacecraft and habitat construction. In the same time, the fusion of artificial intelligence and quantum computing, known as Project Quantum Mind, makes significant strides. By 2051, this project successfully integrates advanced AI algorithms with quantum processors, catalyzing breakthroughs in medicine, environmental science, and theoretical physics, realms once thought to be centuries away from such understanding. The Moon, not to be outdone, once again captures the world's imagination. In 2065, the Endeavour mission reignites human presence on our lunar companion, establishing the Lunar Research Colony. Scientists and engineers at this outpost work on harnessing the Moon's resources and studying the cosmos, while also serving as a critical gateway for deeper space missions. As Martian life becomes the new normal, a robust travel route develops between Mars and the Moon, facilitating the exchange of resources, knowledge, and people, knitting the celestial neighbors closer together. The fruits of Quantum Mind project begin to show in 2072, when the first quantum artificial intellect, known as Athena, starts to achieve breakthroughs by unraveling the mystery of dark matter. Over the next few years, Athena becomes more than a symbol of human progress, it becomes an essential ally in our quest to understand the universe. Its insights make the ambitious Explorer mission to Jupiter's moon Europa in 2093 not only possible but safer and more efficient. Athena provides advanced navigational intelligence and deep cosmic insights. The Odyssey spacecraft, a marvel of late 21st century engineering, harnesses the power of fusion propulsion, allowing it to traverse the vast distances of space with unprecedented speed and reducing the journey to Europa to just 20 months. This breakthrough in propulsion technology promises a new era of interplanetary travel where even the outer reaches of our solar system are within closer grasp than ever before. By the early 22nd century, around 2105, humanity witnessed an unprecedented synergy between themselves and artificial intelligence. Project Synergy, launched in the late 2090s, saw AI becoming an intrinsic part of daily life, enhancing personal and professional experiences. Around 2090, the development of a new AI, named Apollo, began, with its deployment in 2096 focusing on space exploration and technology. Apollo worked in parallel with Athena, an AI that had been making significant strides in Earth's development, focusing on social, environmental, and health advancements. Together, these AIs represented a duality of purpose: Apollo, reaching out to the stars to aid humanity's quest beyond Earth, and Athena, ensuring the well-being and advancement of human society on the home planet. In healthcare, AI-driven diagnostics and treatment planning, powered by Athena's deep learning, became the gold standard. As the 22nd century progressed, humanity embarked on an ambitious quest to enhance its own cognitive capabilities. The Neurofrontier Initiative, which began around 2110, focused on expanding human memory, processing speed, and even sensory perception. By 2125, neural implants and interfaces, once experimental, became refined and widely adopted, offering unprecedented access to information and communication directly through thought. These enhancements extended beyond the intellectual to emotional and experiential, allowing for deeper empathy and understanding, fundamentally changing human interactions and relationships. Athena's contributions were invaluable in this realm, providing insights that helped tailor neuro enhancements to individual needs and optimizing the interfaces for various applications. As humans ventured further into space, Apollo provided critical support, helping design cognitive enhancements that enabled astronauts and colonists to adapt to the new challenges of extraterrestrial living. Apollo's advanced algorithms played a crucial role in supporting and enhancing the safety and efficiency of space missions, which included the construction of habitats on Mars and beyond. Apollo's contributions were instrumental in collaboratively planning grander structures in space. By the late 2120s, with insights and analyses provided by Apollo, humanity began constructing larger, more complex space stations orbiting Earth, Mars, and the Moon. These served as hubs for research, commerce, and transit. By the early 22nd century, the ambitious mission, Explorer 1, in 2093, utilizing the Odyssey spacecraft, marked humanity's first robotic venture to Europa, Jupiter's intriguing moon. This mission, primarily involving sophisticated robots and drones, was designed to gather extensive data and prepare the way for future human explorers. The information collected by Explorer 1 proved invaluable, revealing Europa's potential for an underwater ocean and the possibility of extraterrestrial life. With the groundwork laid by Explorer 1, and through a collaborative partnership between human engineers and Apollo's strategic planning, humanity was ready for its next giant leap. By the mid-2130s, the Explorer 2 mission was launched, this time carrying astronauts aboard the Odyssey 2 spacecraft. This mission represented not just a journey across space but a journey into the unknown depths of one of our solar system's most mysterious worlds. Upon arrival, the crew began the monumental task of establishing Europa Outpost 1, the first human base on Europa, designed for both surface and subsurface exploration. By the early 2140s, Europa Outpost 1 had evolved from a preliminary base into a sophisticated hub of scientific activity. Building on this success, humanity commenced the construction of the Europa subsurface habitats in the coming years. These habitats, securely positioned in the Moon's icy shell above the vast ocean, allowed scientists and explorers to study Europa's mysterious waters directly. They searched for signs of life and sought to understand the complex environmental dynamics of this alien world. Throughout this period, Apollo was instrumental in the planning and execution of these missions, providing computational power and advanced algorithms needed to navigate Europa's challenging conditions. The synergy between human creativity and Apollo's analytical prowess was not just about reaching new worlds, it was about creating new homes and expanding our understanding of life's potential in the cosmos. As humanity entered the mid-22nd century, the Galactic Pioneers program, launched in 2162, marked the beginning of an ambitious era of interstellar travel and exploration. Utilizing advanced propulsion methods developed from fusion techniques pioneered by the Odyssey spacecraft, these missions began targeting nearby star systems for exploration and potential colonization. By 2175, the first feedback from these brave voyagers started to trickle back to Earth, offering glimpses of alien worlds and the promise of new homes for humanity. In 2184, spurred by these promising discoveries, the Terra Nova initiative commenced, focusing on the formidable task of terraforming select exoplanets. Guided by Athena's ecological insights and Apollo's strategic planning, early terraforming projects employed a range of technologies from atmospheric processors to microbial bioengineering, aiming to transform inhospitable planets into environments fit for human life. While these efforts were set to unfold over centuries, the initial groundwork laid the foundation for humanity's multi-planetary future. Amid these profound exploratory and terraforming endeavors, 2193 marked a revolution in communication with the advent of quantum entanglement communication technology. This allowed for instantaneous data transmission, irrespective of distance, initially linking Earth with its interstellar missions and, by 2001, becoming a standard communication method across human settlements in the solar system and beyond. As humanity achieved Type 1 civilization status in 2218, harnessing the energy of an entire planet, these advancements in travel, terraforming, and communication were not merely isolated achievements but part of a larger tapestry of human progress, weaving together a future where humanity's presence, influence, and community extended across stars and galaxies. As the 23rd century unfolds, humanity embarks on the transhuman era, a period marked by the fusion of human capabilities and technological enhancements. By 2270, the Transcendence Initiative catalyzes this new age, focusing on expanding human potential through advanced cybernetics, genetics, and neural enhancements. As people explore augmented abilities, the first neo-human communities arise by 2285, embodying a new stage in human evolution. These societies, celebrating the diversity of transhumanism, become beacons of innovation and philosophical exploration. Meanwhile, the architectural dreams of humanity grow ever more ambitious. Around 2290, the construction of celestial arches, massive space habitats, begins. Orbiting Earth and other celestial bodies, these structures are marvels of engineering and design, capable of housing millions. By 2315, with advancements in materials science and construction technology, the first orbital ring around Mars was completed, serving as a testament to human ingenuity and a hub for interplanetary trade and travel. As the century progresses, the distinction between biological and artificial life becomes increasingly fluid. Neural interfacing and genetic customization are widespread by 2320, prompting deeper philosophical inquiries into identity and consciousness. In 2345, the Harmony Nexus is established, a space station symbolizing the era's ideals, where biological humans, transhumans, and sentient AIs coexist and collaborate. Here, the potential for what humanity can become is explored in its fullest diversity. By the 2400s, humanity's reach and ambition extend even further. The construction of a partial Dyson swarm around a neighboring star begins, a project that harnesses the energy of an entire star to fuel civilization's expansive endeavors. This period is not just about the physical transformation of humanity and its habitats, but also about the cultural and existential evolution. The transhuman era, with its artificial worlds and megastructures, represents a pivotal chapter in the story of humanity, a time of profound change, reflection, and aspiration towards a future where the possibilities are as boundless as the universe itself.